Hi, everybody, and welcome to Room 9, the region's largest classroom. My name is Mrs. Brewer, and I am a third grade math teacher at Gordon Bush Elementary School in the East St. Louis School District. And today I am here to teach you a third grade social studies lesson. Wait, what? Not social studies? Then what do I teach? That's right, math. So I'm here today to teach you a third grade math lesson. So I hope you have your multiplication brain on, because today, guess what we're going to be working with? You are correct if you said multiplication. Of course, it is one of my favorite things. So, boys and girls, let's do a quick check-in. How are we feeling today? Give me a thumbs up if we're feeling great, thumbs down, not so great, or thumbs in the middle. It's Monday, we're back, but it's Multiplication Monday. Oh, I see some thumbs in the middle and some thumbs down. Hopefully, boys and girls, by the time that we are done, you will be just like those other boys and girls with those thumbs up, because who can have a bad day when we have math, right? Who can have a bad day with math? Not me, not ever. And you know why you can't have a bad day with math, boys and girls? Because we have strategies, right? Nothing's hard if we stop and break it down and use our strategies. All right, boys and girls, so let's go ahead and stretch ourselves out just a little bit here today. Go ahead and put your arms out straight to the side. Pick one side to face. And I want you to just kind of lunge just a little bit. Just kind of drop down a little bit. Stretch out those arms. Lunge your legs, bend your legs, and let's sit like this for a second. All right, boys and girls. Now take your arms. Put them up high. Put your hands together. Do the same thing, boys and girls, with your feet. Put your feet together, touching. Stretch out. Make yourself as tall as you can. Let's do the same thing. Let's make ourselves as small as we can, boys and girls. Can you go down and touch your toes now? Stretch it out. Slowly start working your way back up and around in your back as you do, all right? Now let's put our arms out to the side again, boys and girls. This time face the opposite direction. I went this way before, so now I'm going to go this way, okay? So I'm going to turn and face that. I'm going to kind of bend my knees just a little bit. And we're going to stretch it out this way, boys and girls. Bring it on back. Put your hands behind your back. Start raising those arms up just a little bit behind you. All right, and now let's take our head to one side, head to the other. Take it back. Take it forward. And now let's take it to my board. Okay? So here, boys and girls, last week we practiced counting by 6s and 7s. Today we're going to drop it down low again. Let's practice some 3s. Okay, I know we kind of went through those before, but we're probably going to see a lot of 3s going through, and this might be one factor that we might be able to skip count by quite a bit. So let's practice counting by 3s, boys and girls. You ready? You ready? I see you. You're ready back there. All right. Let's count. 3, 6, 9, 12, 15. Try it again. Should we go a little faster? Put a little rhythm to it. What do you think? Ready? 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. Let's try it now, just you guys. Ready? Good job. Now let's see if we can count to 30. starting with 3. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Let's go again. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We speed it up a little bit? You think we can? Maybe, because the numbers are here. Just repeat after me. Get it stuck right here, boys and girls. So anytime we have to skip count by 3, hopefully it's 6 and we can use that. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. One more time. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now you try, boys and girls, on your own this time. Ready? Go. Good job, boys and girls. So remember, if we ever have a problem multiplying by 3, we can now use the strategy of skip counting by 3s because you just counted by 3 with me, right? Okay. So today, boys and girls, we are going to continue working on multiplication, like I said, and we're going to review a few of the topics we've talked about, and we're going to make just a little more sense of them, if you will, boys and girls. I kind of work through a few problems just to make sure that we have our concept down. So when you get to multiplication in school, you're going to have no problem when you get to these word problems and arrays. You're going to have to say, I got this, okay? I already know how to do this. I am good to go, all right? So let's review a few things, boys and girls. If I give you an array that looks like this, okay? See my happy little monsters here, boys and girls? Okay? What multiplication equation can you write from this array? Take about, I don't know, boys and girls, 15 seconds. See if you can find a multiplication equation to write based off of this array. And go. Some hard work going on back there, boys and girls. All right. What'd you get? I hear someone out there telling me that they have gotten 2. Well, let me go ahead and write this here. Skip counted by 3s. So now it's going to go away in the breeze, right? All right, we skip counted by 3. So I heard someone out there tell me that they had gotten 2 times 4. Did anybody else out there get 2 times 4? Okay. See, some of you out there had gotten 2 times 4 as well. How did they get it? Well, if you go back to what we've been working with the past couple of weeks when we were talking about arrays, we said when we're talking about equal groups, we usually take the number of groups times how many in each group. So when we made our arrays and we looked here, we were using the number of groups that we had and turning them into rows. This is 1 row, this is 2 rows, okay? Or it could have went back to 2 groups, okay? So I'm going to write 2 as my first factor in my multiplication equation. And then the second part was how many in each row. That's kind of what we do here, right? Instead of a group is a row, right? How many do we have in each row? Oh, 4, right? We've got 1 monster, 2, 3, and 4. So our equation that we could write from this was 2 times 4. And let's go ahead and solve it since we're here. How do we solve it here? Right, we can either just count them all up, I heard someone say, or someone said, I've got 2 rows of 4. I can count by 4, 4, 8, right? Or I can just skip count. If I look here, I can skip count again. Now I have 4 rows of how many? Oh, four columns, not rows. These are columns that go down of 2, 4, 6, 8. I could skip count by 2s that way. See how I have 2 in each column? All right. So what was that question? Oh, what's a row and what is a column? That is a great question. Well, when I think about rows and columns, let's stick with our monsters we have here, boys and girls, for rows and columns, okay? So when I think about a row, I always tell my students, think of row, row, row your boat. And if I'm rowing my boat, where am I trying to go? Usually across a lake or a pond, right? Think about that. You're in a boat, you're rowing, okay, across. So that's the way a row goes. A row goes across. So my row goes this way, okay? And then do you remember the other word I had mentioned here? Oh, I mentioned column. So if a row goes across, which way do you think a column would go? Right, a column goes up and down, right? And I always think about a column, right? Let me try to fit it in here, boys and girls. All right, sorry, I gotta turn this just a little bit. A column goes up and down, all right? And in this word column, boys and girls, you see the letter L. And I would think that a letter L is a good example of up and down, right? So a column always goes up and down. Right? So we've already solved our problem here. 2 times 4 equals 8. But boys and girls, is there another multiplication equation I could have gotten from this very same array? And I'll bring it closer so you can see. The other week we talked about the commutative property. And that was saying it doesn't matter which order we have our factors in, right? We're still going to get the same answer. The same product, as we know, is the answer to a multiplication problem. What happens if we kind of just picture it like this? How many columns do I have? Well, we'll turn it back this way. How many columns do I have? Oh, now I have 4 columns, right? 1, 2, 3, 4. Always had 4 columns, right? So now I could rewrite this equation as 4 columns times, how many rows do I have, boys and girls? You're right. I still have 2 rows. 1 row, 2 rows. Rows go across. So here is, let me circle here, boys and girls. Here is 1 row across, right? Here is 2 rows of monsters across. So I would also have 4 times 2. And what does 4 times 2 equal? You're right. If I would count up my monsters, I would still have 8. Good job, boys and girls. Good job. All right. So even though we can write these either way with commutative property, it's still a good idea when we talk about equal groups to take the number of groups times how many in each group. So with our array, I had 2 groups or 2 rows of 4, right? But we could also write it as 4 groups if we looked at our columns of how many? 4 groups of 2 to have gotten this. But most of the time, boys and girls, you will see people write it as the number of groups times how many in each group. Just if we keep it kind of that uniform thinking a little bit with writing these equations that we're getting off of word problems and such, then if I had someone else draw a picture, they would know how many groups and how many in each group of what we're talking about, okay? So let's see a little more, boys and girls, what I mean by trying to represent what we're actually seeing, okay? So here is my word problem today, boys and girls. Oh my gosh, did you just see that? We just had an octopus fly onto my word problem. Did you see that? Can you see that octopus? Did you hear it? How do we miss that flying in, boys and girls? I don't know how we missed it, okay? So let's see what sense we can make of my problem now that the silly octopus landed on it. It says an octopus has 8 what? What do we know an octopus has 8 of? Oh, legs. That word's probably legs, right? An octopus has 8 legs. Kyle counted 4 octopi in a tank swimming around. And the octopi is just a plural word form of octopus. How many legs did Kyle see? Okay. Well, what do we know is happening here? What are we talking about, first of all? We're talking about octopus, right? And we know that they have what? You're right, 8 legs, right? And what were these octopi doing? They were swimming in a tank. You're exactly right, okay? And what are we trying to solve for? How many legs they have, right? So we know one octopus has 8 legs, but we're talking about how many here? You're right, 4 octopi, okay? So I'm gonna go ahead and hang this problem up, boys and girls, behind us. We know this is what we're working with now, all right? I'm gonna go ahead and erase my problem so we don't get confused, okay? So here's our problem. Here's that silly little octopus that jumped on right here on me, okay? So we were talking about we had 4 octopi and each one had 8 legs, okay? I know that Miss Brewer said we can work with our commutative properties from, right? But let's think about how we would actually draw this. So if I had 8 octopi, we have what? 4 octopi. Where did I get 8 from? You're right, because they have 8 legs. Oh, almost stepped on another one. I think another one's swimming in, boys and girls. You're exactly right. We had 4 of them with 8 legs, right? Okay. So if I were to draw a bar model, a bar diagram, to help me see this, how many boxes do you think I would need to draw, boys and girls? Oh, okay. So 4 octopi, right? And each octopi has how many legs? Right, 8. Okay. So I went ahead and already have drawn our bar diagram here. So each box represents what? You are right, the octopi. And what does the 8 represent in each box? Right, the number of legs. Okay. So what would my multiplication equation be for this problem based off of my bar diagram here? What would it be? Well, I'm going to go back to my rule. How many groups do I have? I have 1, 2, 3, 4 groups, right? And then of, like anytime we say of, we're going to write that multiplication sign, right? That X that symbolizes multiplication. All right. So we have 4 groups of, and how many were in each group? Right, 8. 1, 2, 3, 4 groups and 8 in each group. So my equation would be 4 times 8. Exactly right. Equals. So I'm going to go ahead and use repeated addition to help me with this one. Okay? So this time, I know usually boys and girls, I tell you to start with a bigger number and then add that the smaller number of times. But do I have to do that? We don't. I usually ask you to do that just because it's less adding. Okay, but we can add 4 how many times here? Right, 8. So I can have 4 plus 4 plus 4 plus 4. Okay, halfway there. Plus 4 plus 4 plus 4 plus 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm adding 4 8 times. 4 plus 4 is 8 plus 4, right, 12. 12 plus 4, 16. 16 plus 4, 20. 20 plus 4, 24. 24 plus 4, right, 28. And 28 plus 4, 29, 30, 31, and 32. So 4 times 8 equals what? 32. Okay. Once we have that multiplication equation, we can use any of these strategies that we've been using, boys and girls, to help us solve it. Once we have that equation, it doesn't matter which of these strategies we want to use, we can use any of them to help us solve this. Okay. So how many legs do we see? You're right. We saw 32 what? 32 legs. So we didn't, I guess Kyle saw it. We weren't at the aquarium with him. Have any of you guys had a chance to check out the new aquarium in St. Louis? For those of you that have, do they have octopus there? Octopi? Cool. I haven't got a chance to go there yet, so I'm not sure if they have it or not. All right, so question, boys and girls. So I know that my equation here was 8 times 4. Or 4 times, I'm sorry, it was 4 times 8. I have 4 groups, right? Of how many in each group? 8, right? Okay. So look at this bar diagram I have here. Would this bar diagram also represent the problem I just did? How many groups do you see here, boys and girls? 8 groups, right? So now I have 8 groups of how many? How many are in each group? 4, right? So what would my multiplication equation be? 8 groups of 4 would be 8 times 4, okay? So what does 8 times 4 equal? Well, I know 4 times 8 equals what? We just did that one, right? It equals 32, right, boys and girls? So what would 8 times 4 equal? 8 times 4 would also equal what? 32. So is this bar model correct or is this one correct? Or does it not matter? Well, boys and girls, even though they both gave us 32 for the answer, which one actually represents our problem? Do you think it's the one on the top? Put your hand on your head. Do you think it's the one on the bottom? Put your hands on your hips. What do you think? My hands are on my head because I know that I counted 4 octopi with 8 legs. So here I have 1, 2, 3, 4 octopi. Each box represents a different octopus, right? And I know each octopus has 8 legs. When I look down here below, I'm seeing 8 groups of 4. Did I have 8 groups of octopi, 8 individual octopus? No, I didn't, did I? And even though I didn't have 8 octopi with 4 legs, did I? No, I had 4 octopi with 8 legs. So the equation, even though they both equal 32, we typically say, we will say it's 4 times 8 because it needs 4 groups of 8. Okay? So even though this gave us the same answer, you might have gotten that answer right on the test, but your bar model wouldn't have represented our situation we have, would it? No, it wouldn't. Okay? So when we are doing these, boys and girls, you need to visualize what we have going on. I can almost picture these crazy little octopus in each one of these boxes. Okay? And in fact, if I really was artistic, I might have been able to draw one in each box. But in math, we just represent with the value that we need here, which was 8. Okay? So even though, boys and girls, they both gave us the same answer, only one of them truly represented what the problem was telling me. So always, 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 boys and girls, start out with that word problem and think about what it's asking and what your bar model is actually representing. Okay? So boys and girls, I hope you have a fantastic Monday night, and I will see you back here tomorrow to continue on our multiplication finale week. Multiplication's never going to go away. We're going to use it a bunch, boys and girls. So don't think this is completely it, okay? All right, boys and girls, you have a wonderful night, and I will see you back here tomorrow. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.